Hi YouTube, my name is Yusuf and you are watching my news channel. Today I will be covering a little bit of space weather as usual, but also the weather. So let's start with space weather conditions. We are actually in a solar wind stream flowing from this southern coronal hole as we speak. I think the initial impact was yesterday. This is an overlay of 3 days of worth of solar wind data. We can see in purple that the solar wind speed is peaking around almost 600 kilometers a second, and this might increase even further, and I will show in a minute as to why. Looking at the density, we see that this solar wind is not the densest. It is actually stable, hovering at around 10 protons a second without major increases or dips or anomalous behavior of anything. So the solar wind is actually stable. Looking at the phi angle, we don't see any change in direction, any major change in direction. It's pointing actually away from the sun as we speak. Looking at the BZ component, we see, however, that it goes regularly negative, and this is normal. This is the period of the so-called McFarlane effect, if I'm not mistaken. This is when Earth is actually aligned with the solar wind because of its axis tilt, and this happens always in spring and autumn, so this is actually normal. This might increase the geomagnetic activity, and in fact, if we look at the KP index, we see we are actually in a geomagnetic storm, and this time it is actually sustained, not just a brief spike. So this might produce earthquakes. We will have to see. Looking at the Enlil spiral, so as I said earlier, we might see an increase in speed of solar wind speed, because here we see that it will increase further according to the Space Weather Prediction Center as we enter this area of dark orange, and this means higher velocity, as you can see on the scale. So I think we might see it go to 600 or slightly above, or even flirt with the 700 kilometers a second. However, if you look at the density, unlike the velocity, the opposite will happen. It will completely collapse, and so we will have less density in the solar wind. As we enter this particular area, as you can see, this is almost no pressure at all. But the speed is there, so particle wise it's not the densest stream, but it will increase in speed. So whether this will sustain that increase in geomagnetic effect, this remains to be seen. However, there is something I want to point out, and that is that while we don't really have major space weather conditions, the magnetopause, its position actually is very close to geosynchronous orbit, and at the moment of speaking, it is becoming dangerously close. So this might evolve even further to almost actually hitting that dashed line which represents geosynchronous orbit, which is the orbit of satellites. This is over here basically. So when the bow shock hits, actually touches geosynchronous orbit, this can be dangerous for satellites and cause actually damage to them. But what caught my attention this time, this is actually ongoing, so it's not really a surprise. Our magnetic shield, Earth's magnetic shield, is weakening, and as such, I pointed this out in many videos, it will come regularly close to geosynchronous orbit without any major space weather conditions. As to why, I think the answer might be the Van Allen belts, because whenever this happens, there was also major disturbances happening, major deformations, and they always happen when, strangely enough, the inner electron belt becomes connected to the bow shock. So as you can see, this might be evidence of conductivity. Maybe the Van Allen belts, as you can see, get drained. That's a possibility. As to what's causing this, maybe human intervention, ionospheric heaters, maybe something in space, experiments with satellites and such. I don't know. It could be also of natural origin. Maybe, and this is also just a theory, in my opinion. Earth's core is not molten lava at all. I think there is something like an electron star inside our planet. And maybe it is going through a cycle, I don't know. This is really strange. Here we can see this again. Whenever these deformations happen, whenever the magnetosphere starts acting in a strange way, it becomes distorted, starts to collapse. We see it also in this particular animation, or simulation, I should say. And what you have to see is the closed lines. We see them erratically expanding and collapsing, like here, for example. But as you can see, this is supposed to be an arc, and half of a circle, and it collapses, as you can see, front and back side. So see, here are the lines again. Let me go back, and there you can actually see it clearly. See, this is supposed to be like this, and then all of a sudden, but the data jumps actually, so we're not really, but there it is. You can actually see it. Wait. Yes, between this image and this image, you can actually see it. When that connection happens, the closed field lines all of a sudden disappear. Here they are. Here they disappear. So when that discharge happens, the magnetosphere sort of starts collapsing. Now, this is not really an issue now, but that's because there are no major space weather conditions. Even with the geomagnetic storm, that solar wind is too slow and the density also too low to have any meaningful impact. But clearly the signs are there. When we reach solar maximum, and we will, when there will be X-flares, when there will be large halo CMEs pounding our magnetosphere, just imagine what would happen, what you would see. This might even hit the news at some point if there is damage to satellites and such, but this remains to be seen. Okay, let's move on to the next item, the Schumann resonance. As you can see on the 16, this is clearly the moment of impact of that solar wind, and the increase in activity of the Schumann resonance is ongoing, as you can see. This might again become visible when the solar wind stream increases in speed tomorrow, but this remains to be seen. Earthquake-wise, strangely enough, it is actually quiet. We don't have anything higher than 5 pointers, and this leads me to believe that bigger earthquakes are imminent because of the geomagnetic storm. If I have to guess where, we already have 2 big quakes over here north of New Zealand, so my guess is either around Japan or Chile in South America. And then the spillover effect, the movement that has to be compensated, might produce earthquakes in this region again. around Greece, maybe Iceland will awaken again, the volcanoes there will increase in activity, who knows. Alaska might be prone to earthquake activity, and the reason for it is of course the San Andreas belt that actually blocks, that is actually locked completely, so we might see some compensation movement going here. We might see compensation movement spilling over to South America, but definitely going west of the this side of the ring of fire, because this movement cannot be compensated over here, because this tectonic plate doesn't budge at all. And that movement has to be compensated somewhere. So yeah, I think Japan, Chile, Greece, we will see how this develops. Okay, let's move to the weather. And weather-wise, we have again strange things going on. The polar vortex has again moved to Russia, and that's a big jump. If I have to put it in kilometers, I would say that's almost 1,000 kilometers from its original position. This has implications, especially concerning the jet stream and such, as such the temperatures and the extreme weather events. If you look actually at the Arctic oscillation, we see consequently low values, hovering around negative and slightly positive. Looking at the geopotential height anomaly, we see again positive values, and they are sustained. I thought that this would subside around the 22 of the 23 April, but now I think the cold might even be sustained, especially in Europe. I'm not talking about other parts of the world, but in Europe it has been unseasonably cold. I mean, we are here having 10 degrees each day, while we should have at least 15. So it's cold, of course. We have negative values, anomalies, cold anomalies, and this will be sustained. Very cold weather here in Belgium and other parts of Europe. And as you can see, oh yes, the only good news is that we don't have any major stratospheric warming, and as such, we do have everything above 300 millibar is actually a negative value, so there is still a chance of having either a second part of a warm spring or a warm summer. But we will see. For this to happen, this has to disappear, and we would have to see negative values again at the surface. Okay, if we look actually at the weather, we can see that indeed the jet stream is completely off of its normal positioning. So normally you would have a wave-like, and I will go to April the 27th, because this looks like again a normal jet stream pattern as it used to be. This is only a prediction, of course. Whether this will be like this remains to be seen, but this is how it's supposed to be looking like, and this is how it looks like now. You can see that, for example, this high pressure system stretches from Africa all the way almost to Iceland. I mean, this is because the polar vortex is located over here, and so the jet stream has a tendency to search for it, to connect with it, and then we have, of course, a breakup of the jet stream pattern, a blocked jet stream pattern, and it has a tendency to go straight to the Arctic, where the polar vortex is located over here. If it was located here, we would have that typical circular wave motion, and you wouldn't see it actually go all the way to the Arctic region. but unfortunately it does. And this means extreme weather, it means cold weather for Europe, and also extremes, and also in other parts of the world, because the jet stream evidently covers, this is the jet stream of the northern hemisphere, so I'm expecting also temperature anomalies over the United States, of course, but also over Russia. Here in Europe, well, these anomalies translate themselves into cold weather, colder than usual. And if we look actually, let's take a look at the world temperature map. You can actually almost immediately see it. Europe is too cold, and when we put the anomaly, we can clearly see there is a blob of cold. And let me just put, for example, no, not this. Yeah, we already seen this. No, it's actually quite visible in the anomaly. I thought there was a 500 millibar with temperature, but this is only wind speed and height. We don't need this. So we can clearly see that it is showing cold anomalies, but also in the United States, strangely enough, we have extremes everywhere because of this strange position of the polar vortex, and thus the slowdown of the jet stream and the elongation, increase in amplitude of its wavelength. When this will stop, I don't know, and frankly, these predictions were time and time again wrong, because I don't think you can really predict the weather when it is actually like this. This is not normal. I don't think they can compute this even in the simulations to know what weather it will be. And this has already shown, when I look at my weather forecast, it has been wrong for days and days and almost more than a week, when they actually showed that it would be 20 degrees this week, and yet we have 10 degrees, and the entire next week the same thing, cold temperatures all the way. Let me show this actually. No, we don't need Yahoo, we need Google. Let me put this in English. Oh yes, it's already in English. Okay, usually I put it in Dutch, but okay, since I am talking in English, let's just... yes, this is actually the overlay. So as you can see, 19. Oh, this is actually a forecast until, yes, until the 1st of May. Way too cold. I mean, these are actually temperatures for the end of November and beginning of December. So when you see this in the month of May, that's not a good sign. This is a very, very cold start of the spring season, which is completely non-existent, if I may say so. At the moment of speaking. And as you can see, I mean, they will drop, not increase. As you can see, for example, Sunday 13 degrees, Monday 15 degrees, and extreme weather, rain, thunder forecasted 14 degrees, and then it keeps going lower. And actually, the previous week they were actually forecasting 20 degrees for this particular for these particular days. So you see, they were completely wrong, and this is because of these extreme conditions. So will there be a change? Will everything normalize? I hope so, but this is a very strange situation, to say the least, with the polar vortex taking a stroll to Russia here and then. I don't know. Let's just hope for the best, but doesn't really look good. Okay, so it's almost the end of the video. I hope that you enjoyed it. We will end, of course, with a philosophical quote. Oh yes, and don't forget to hit the like button if you actually enjoyed the video. And most of all, don't forget to subscribe, otherwise you will miss any future content, and this would make me very sad. So I do believe that the next philosophical quote, oh yes, is watch out for the patient man's anger. So people that tend to stay silent and exercise patience are the ones actually hiding their bad side. So you have to be cautious when provoking someone like that. That's what this actually means, and this is actually true. Okay, this is the end of the video, a lengthy one, but I wanted to show this strange weather pattern. And this is it, I guess. Yes. Okay, thanks for watching this video, and I guess I'll see you next time. Bye bye everyone. Stay safe.